Okay, 10.5, measures inside and outside a circle. So our first scenario is where the vertex is on the circle. We have a tangent and a chord. The intersection is on the circle, which creates two angles here. Angle 1 is half the measure of this arc BA. So take that arc, divide by 2, and you give you this angle. You can take this angle and multiply by 2, and that would give you the arc. Over here with angle 2, we can take that angle and multiply by 2, and it would give you this arc BCA. Or you can take this arc ACB, divide by 2, and that would give you that angle. Make sure you see that both ways. So let's look at some examples. The first one asks you to find the measurement of FH. Remember that M means we're looking for degrees. So we're looking for the measurement of this arc. So the first thing we need to do is look at this intersection here. We have two angles. 129 is this angle here. What's the measurement of this angle here? 180 minus 129, what does that give me? 51. So if this angle is 51, we can multiply by 2, and that'll give me angle HF. What's 51 times 2? 110. More than one way to approach this. You also could have done 129 and multiplied by 2, which would give you this big arc, HGF, and then subtracted that from 360, and that would have given you the other arc. Just another way to look at it. JKL, we're asked to find the measurement of, remember I showed you guys to make sure you follow with your finger? So if you start at J, you're going through K and ending at L. So we're looking for the measurement of this arc, but we have no measurements there. So what do these mean, these little arcs? They're all congruent. So if I know that these three arcs form that straight line and they're all congruent, each of those angles have to be what? 60, because 180 divided by 3, that means this angle is 60, this angle is 60, and this angle is 60. So for this angle, that's 120. So if that angle is 120, what's this arc have to be, or this? Good. We're doubling it. Okay, comfortable with this one? Okay. Vertex outside the circle. So we have three different scenarios for this rule. We have a tangent and a secant. Here's my tangent, here's my secant. Remember, a secant is a line, whereas a chord is a segment. Remember that back from 10.1. So if we have a tangent and a secant, we have the arc, the bigger arc minus the smaller arc divided by 2. So if we're looking for this angle, I'm taking this blue arc, this bigger arc from B to C, subtract the smaller arc A to C, and divide by 2, and that gives you that outside angle. All of these are very similar, they just look different. The next one is two tangents. With two tangents, look at how the average look of it, I guess. We're going to take the bigger arc, PQR, subtract the smaller arc, PR, divide by 2, and get that outside angle. So we are subtracting the two arcs, bigger arc minus the smaller arc, divide by 2, that gives you that outside angle. Two secants. So with the two secants, again, same idea. The bigger arc minus the smaller arc, divide by 2, that gives you that outside angle. And again, remember, we're looking at the actual degrees. So you're subtracting those degrees, dividing by 2, and that gives you that outside angle. So they look similar, they all have this outside angle, but it's either tangent to secant, two tangents, or two secants. So let's look at some examples with that. So the first one, we need to find the measurement of this outside angle. So this one is the second one with two tangents. So what we're going to do is take this arc, which we already know, and subtract this arc. So what you need to remember is, though, even though my picture might not look like it, it's only touching it in one point. These lines are only touching it in one point. So this arc actually starts right here and goes all the way down to here. The next arc starts here and goes to this point. So when you put those two things together, they do add to 360. So if I know this one is 243, what does this one have to be?
117.
We're going to subtract from 180 and we get 117. So I want you to make sure you're setting this up so that when you get to harder problems like this one, you're able to do it not just in your head. So we're going to take the bigger arc, so the measurement at angle 1, the bigger arc minus the smaller arc, these are the ones that are associated with that angle, divide by 2, and that gives me angle 1. So what's 243 minus 117? What does that give me? Do you have it?
126.
126 divided by 2?
63.
So the measurement of angle 1 is 63. I do want you to set it up this way because these are easier problems where the unknown is all by itself. You could have other problems where the unknown could be somewhere else. So be careful that you know how to set up your equation. The next scenario, we have two secants. So the same idea. I need to take this arc, subtract this arc, divide by 2, and that gives me that outside angle. I don't know this one, but I can subtract from 360. So 360 minus 104 minus 111 minus 104, what is this arc?
41.
So I'm going to take my bigger arc, the measurement angle 1, 111, this arc minus this arc, divide by 2, and that gives me the outside angle. So what's 111 minus 41?
70.
70? Yeah.
Yeah.
70 divided by 2?
35.
So far, so good? Okay, look at this one. This one's different. This is what I'm telling you to make sure that you know how to set up your equation. So we have this arc from here to here as 13 minus 6. This arc is from here to here as 5x minus 4. And this outside angle is 54. So I'm going to do this on the board just to make it a little bit easier for you guys to see. So the outside angle is 54 equals the bigger arc minus the smaller arc. The bigger arc is identified as 13x minus 6, and we're subtracting that smaller arc and dividing by 2. Be careful, those parentheses have to be there because the formula says the bigger arc minus the smaller arc. This entire thing is that smaller arc. That subtraction is important because then you're going to have to change the signs. So my next step, make sure you're going through step by step, not skipping things because you can make a mistake. So my next step, I'm going to distribute that minus to everything in the parentheses. So 5x becomes minus 5x, 4 becomes minus 4. All I did was get rid of those parentheses. Next up, I'm going to simplify by combining like terms. 13x minus 5x gives me 8x. Negative 6 minus 4, that gives me negative 10. At this point, I could multiply by 2. I also could divide both of these terms by 2. It's just in preference. I'm going to divide by 2 because that's what makes sense to me. Because remember, that 2 is the denominator for both of these terms. Then I'm going to add 5. 59. What am I doing? So 59 divided by 4, what's that give me?
14.75.
So this is the kind of problem that it's important that you're able to set up your equation and not just try to do it in your head. Okay, one more scenario we have. Vertex inside the circle. I think this is the one that's a little bit tricky. So where the vertex is inside the circle, this is where we have two chords that intersect. And I want to kind of draw you guys another picture here. So if I have an intersection, it looks like this. This angle, angle 1, to find that angle, we're averaging the two arcs that are associated with it. Biggest mistake is that a lot of times you guys will assume that that's the center of the circle, even though it obviously is not. This is not a central angle. So you can't just say that it's half or equal to this arc. You can't do that. This formula tells you how to find it when you have those two chords that intersect. So this angle and this angle are going to be the same. They're vertical. That goes way back to what we've learned a long time ago. Whatever one of these angles you're looking for, it doesn't matter because they're the same. The two arcs that are associated with it are these two blue arcs. So you're looking at that X, and then we have two arcs that we need to pay attention to. This formula tells us to average those arcs. which means to find this angle, this arc plus this arc divided by 2 will give you that angle. There's also the opposite way. These two pink angles are going to be vertical and equal. Whichever of those that you're solving for, these two pink arcs are the ones that are associated with it. So to find one of these pink angles, we're going to add and divide by 2 these two pink arcs. Okay, let's look at some examples with that. So the first one, they're asking us to find the measurement of this angle. So the measurement of that angle is these two arcs that are associated with that angle. We're going to add them and divide by 2. So the measurement of angle 1 is 116 plus 140 divided by 2. What's 116 plus 140? What does that give me? 256 divided by 2?
128.
So this angle is 128, and again, that vertical angle would be the same. One more example. We're asked to find x. This is a little bit different. So we're given this angle, but we don't have the two arcs that are associated with it. We know nothing about it, nor can we use the idea of 360 and subtract. But what we can do is notice that these two are supplementary. If this is 137, what's this angle? Now I have a scenario that I can work with. So this 43 angle is the average of this arc and this arc. So I can say x plus 25 divided by 2 equals that angle. Let's multiply by 2 on both sides and subtract 25. What does that give me?
61 equals that.
Thank you. So make sure, this one you can probably do in your head. Be careful that you know how to set up your equation because they're not always going to be that easy.